Okay, let's now focus on column 8, where we ask the question, is the internal energy change positive, negative, or zero? To answer this question, we need to know something about the temperature and the relationship of temperature to internal energy. So let's review a little bit. That the internal energy change for an ideal gas is expressed as the mass times the integral of the specific heat, which is a function of temperature, integrated with respect to temperature from state 1 or temperature 1 to temperature 2. So if we perform this integral and treat CV as an appropriate average value or as a constant, we can write then that this is a mass times CV average and final temperature minus initial temperature. So we clearly see that if T2 is greater than T1, we will have a positive change associated with that. We will know then that delta U is going to be positive, and similarly if T2 is less than T1, that clearly implies then that the internal energy change was negative. And of course, no change, zero change in internal energy. So let's go back now and look at the plots that you have for temperature with respect to volume for these two processes, constant pressure expansion and a constant temperature expansion. So we see from the plot immediately here that T2 is greater than T1, and we would conclude then that we must have a positive internal energy change. So let's graphically redo that here. So here we have TV, and we can put on here our constant pressure expansion from V1 to V2, initial state to final state, and our isothermal or constant temperature process then comes out here. So this would be then state 2P, and this is our constant temperature, so this would be state 2T. And we clearly see then that delta T for the constant pressure process is greater than 0. So we conclude then that delta U must be also greater than 0. And by definition, we see then that for the constant temperature process, the T2 equals T1, so it's almost trivial that delta U then must also be equal to 0. And mathematically, we can go back and write this as well. We know that the temperature is equal to P over mR times V1, just rearranging the ideal gas equation of state for the constant pressure process. And we can write then similarly that T2 is the same slope times V2, and clearly then T2 minus T1, just mathematically subtracting the second equation from the first, gives us this expression. And we immediately see that since V2 is greater than V1, our definition of an expansion, that delta T, then T2 must also be greater than T1. And mathematically, we have then clearly also shown that delta U must be then positive, greater than 0. So we can put that in the space here, that this is definitely going to be a positive quantity. And for the isothermal expansion, we see by definition then that this is going to be 0.